In this lecture, we're going to see what is meant by passing parameters to a function by value. And we're going to look at an example of that. Here we have a simple function called, say, age. It's going to take one parameter, which is an integer called age. And in the body of the function, we are printing out the age after incrementing it. Suppose this is something useful for your program. The function is split into declaration and definition. We have a declaration on top here, and we have our definition below the main function. In the main function, we will attempt to use this function. We're going to call it down here, and we're going to pass a local variable, which is called age, as our age. When we do that, we expect this to print you are 24 years old because we're going to increment the age, and we're going to say, hello, you are 24 years old. This is what this program is going to do. But we want to keep track of how the outside variable here is going to change and the age we have passed as a parameter here. Because this age we pass as a parameter is not going to be the same as the age we have on top here. What we pass here as a parameter is going to be a copy of the actual variable that we passed here. And this mechanism is called passing a parameter by value. And what you really pass is going to be a copy, and what you work on inside the body of the function is not going to be the original stuff you passed as an argument to the function. So we're going to try and prove that here. We're going to print the age before we call the function. We're going to print the age after we call the function. And what we print here is going to be the outside variable, because here we are in the scope of the main function. Inside the sayAge function, what we're going to be modifying is a local copy. So we expect the age here to stay the same before and after the function call. So the way this is going to work, when control hits this function here, it's like we're going to have a situation like we have here on the left. We're going to set up local copies in the function that are going to contain whatever was passed as an argument to this function. And this age here was passed as an argument to our function. So we're going to have a local copy of this age, and we're going to store it. And it is what we're going to be manipulating in our program. When the function goes out of scope, the local copy is going to die, and the outside variable we have here is basically going to be unaffected. Let's head over to Visual Studio Code and show you this in action. Okay, here we are in our working folder. The current project is passed by value. We're going to grab our template files, and we're going to put them in place in the correct project. And we're going to open this up in Visual Studio Code. Let's do that. We're going to open the folder that contains the project passed by value. Let's do that. We are going to open it up, and we're going to go in the file and clean it up a little bit. And we are going to set up our function. It's going to not return anything, and it's going to say age, and it's going to take an integer, which is going to be our age. And inside, we're going to increment our age. I think this is what we saw in the slides. And we're going to say however many years you are old. We're going to say, hello, you are age old. And we can set up a variable in the main function. We're going to call it age. And it is going to contain 23 as our age. We're going to say age, and we're going to pass in our age here. We can do that. If we're trying to run this program, let's try to do that. We're going to build with GCC, and we are going to bring in a terminal we can use to run this program easily from Visual Studio Code here. Let's run Brewster. We're going to say, hello, you are 24 years old. And this is what we expect, because when this function is called, we're going to increment the age, then we're going to say the age. But we want to see what happens to the outside age here if we modify the inside age that we have on this function here that was passed as an argument. And again, what you pass when you are declaring your function is a parameter, and what you pass when you are calling the function is called an argument in C++. Please remember this. Okay, what we pass as an argument is our int age variable, which is local to the main function. And we're going to see what happens to it. Let's print the age and say age before call. I think this is descriptive enough, and we're going to print that. And we're going to go after the function is called, we're going to say the same thing, but we're going to say after call. And And by after, we mean after we call the function, say, age here. I think this is descriptive enough. And we're going to see that if incrementing the local variable to the function here affects the variable that we have in the scope of the main function. Okay, so let's see that. We're going to build with GCC as always. And the build is good, so let's clear and run Rooster. You're going to see that before the call we have 23, and after the call we have 23. We didn't change the second call. This is a classical copy-paste error. We're going to change that for our program to really be descriptive enough. Okay, the build is good. We can clear and run Rooster. And now we have before call 23, after call age is 23. It wasn't changed by what we have inside here. And we can even go further and look at the memory addresses of these guys. Here we can try and print the address of the age variable. Let's do that. We're going to say address of age and put that out here. We're going to say address of age. No big deal here. We can close the pane on the left here because it is taking up valuable space. And we're going to go to the second statement and put in the address of age. And we're going to print that out. We can do that. Now we know the address of operator. Okay, we can do that. And when we hit the body of our function here, we can also print the address of age. No big deal. So we can say address of age. Let's do that here. And we're going to print the address of the local age variable here, which was passed as a parameter here. Okay, now we can build our program and watch those addresses. We're going to build with GCC. The build is good. We can clear and run Rooster. Now you see that the outside variable is going to live at an address that ends in DEC, and the local variable is going to live at an address that ends in DC0. So this is a completely new memory location that we are using, and it is just going to contain a copy of what we passed as a parameter here. And the compiler is going to take care of setting up this copy variable and have it available for use in the local function here. We don't have to worry about that, but we have to be aware that what we are working on in the say age function here is a copy. It's not the original value. This is really all we set out to do in this lecture, making you aware of the call by value mechanism. And the main message is that what you are working on in the body of your function when it is called is going to be a copy of what you have passed as an argument when your function was called here. We are going to stop here in this lecture. In the next one, we're going to see that we can also pass by const value and prevent the modification of whatever it is we passed to the function. Go ahead and finish up here and meet me there.